Hi, my name is Harry Hu. This is Lab 4 Circuits and Capacitors in Physics 2212 or Physics 2. So in this lab, these are the instructions. So in this lab, you will have a choice of experimenting with circuits virtually or using the real lab circuit equipment found in the physics lab, which is preferred. The instructions for this lab are written as if you were using the online CCK kit from the Colorado PHYS project to explore time-dependent voltage and current in a DC system. All of the meters, batteries, resistors, and capacitors with the same value can be found in the physics lab. So we're going to create a 5-minute lab report video. I'm just talking about this experiment. I'm talking about the principles involved, making a model for the system, and I'm going to be using the virtual circuit components for this lab. And here are some formulas and key ideas with change of V equals 0, loop rule, change of V is IR Ohm's law. We're going to have the In equal to I out, which is no rule. Change of V equals Q divided by E0 times A, which is the capacitor difference. We have C equals Q divided by change of V, capacitor, which is the capacitor capacitance. We're going to have log of change of V over log change of V0 equal to negative T over R times C, which is the RC lab formula. This is going to be the experiment model. We're going to be doing two parts of the experiment, which I'll explain later. But basically, there's going to be a part 1 and there's going to be part 2, and you'll see part 1 in the next slide. So this is part 1 of the experiment. We're going to have experiment circuit with 2 batteries, 2 resistors, 2 ammeters. The assumption is going to be some of the resistance is going to be negligible. Details, we're going to have batteries are 1.5 V, resistors are 4700 ohms. Readings, we're going to have change of V equals 3 V, and then I equals 0 A. This closed circuit system is a circuit, and the surrounding is everything beside the circuit. So next, this is the part 1 experiment graph, and then we have the details showing where it's changing from each pathway, A to B, B to C, D to E, E to F, G to H, and then this is the ammeter readings in respect to the volts. And here is the potential difference readings. So I'm just going to let you read what it is, but basically to account for a lot of the 0 volts are not because it canceled out, but it's because like we learned in class, changing vertical directions will always result in 0 volts, no matter what the numbers were at the different parts, like part A or B, but in example B to C, it doesn't matter what B and C are. Excuse me, it's always going to be 0 volts, and it's going to count for horizontal will count. And then we're going to have first one 0 volts total. We're going to have negative 2V equal minus 1V plus 3V equals 0V. I equals 0.02 A. R for 7 equals 50. R 1000 equals 100. And then the R ammeter and the R wire were both found to be 0. We're going to have next part 2 experiment. Batteries connected to bulb, capacitor series. Bulb has 10, bulb has 20, batteries 9, capacitor is 200V. And then we're going to have 11 seconds charging for 1, 12.5 discharging, volt 2, 17 seconds charging, and 22 second discharging. And then we're going to try to start the bulb as bright and then decrease it until it goes out. So this is the graph. You can pause if you want to take a look, but I'm going to move on to the next slide. So this is where we have change of V. I'll let you read that as well. F is around 7 seconds, and part 2 is a little more complicated than part 1, but similar physics concepts. And the slope equation we got was negative 0.17. Quickly skim over this. Similar to other labs, we're probably going to have some human errors that we're going to be in our model difference and source of error. And then last question. So these two questions are really the same. So we're using ideal situations of 0. So a real ammeter would if we use a real one, the circuit would decrease and be lower. and then a real battery would charge immediately. Thank you.